Yeah.
You can start, Swagata.
Yes. Yes.
Yeah,
Yes.
very good day to one and all present here. So I welcome these lecture series of weekly lecture series of on satellite meteorology. So jointly organized by South Asian Meteorological Association (SAMA) and Birla Institute of Technology (MESRA). So today we are going to have the 9th lecture in this series. So now I request Professor Someshwar Das, Secretary, South Asian Meteorological Association, to welcome the panelists as well as the participants. Over to you, sir.
Okay, thank you very much, Dr. Ashim Kumar. Well, Professor AVM Ajit is not here today. So, and even the chairman of the advisory panel, Dr. Z. Bhatia Saab, also is not here today. So, today's distinguished speaker is Dr. Ashim Kumar Mitra. He is a senior scientist at India Meteorological Department, the Satellite Division, and a very good researcher. I have known him for many, many years. He even taught some classes on satellite meteorology at Central University of Rajasthan when I was there. He is also a member of the panel of Satellite Meteorology Committee of SAMA and contributed in formulating the syllabus of this lecture series. So welcome, Dr. Mitra. Members of the organizing committee, Dr. Swagata, Dr. Ashim Kumar, Dr. Rohini, Dr. Mohan, Dr. Mili, and Dr. Divya Prakash. And of course, I missed calling the name of Dr. Thaplia. He's also one of the senior scientists working at SAC, Ahmedabad, and a member of the advisory panel of the lecture series of SAMA on satellite meteorology. Distinguished participants from about 60 countries, ladies and gentlemen, we welcome you all on behalf of the South Asian Meteorological Association and Birla Institute of Technology, MESRA, India. Well, because Dr. Mitra is, I think, here with us for the first time, so I'll just like to repeat a few things which I have already mentioned in the last week. Like, as you know, the total number of registrations of this course as on today is 1,805. Of course, the registration is closed now. The lectures are also becoming popular on the YouTube. All the past lectures are available on YouTube, and the view hits shows that the first lecture given by Dr. Kelkar and also Dr. Sharma was viewed by about 2,360 people, 60 people on the YouTube, while the last week's lecture by Dr. Apial was viewed by 195 people on the YouTube so far. But these numbers, of course, will increase with time, day by day. Well, this is the 9th lecture of the 20 lecture series, as you know. This is a continuation of our efforts on capacity building of the people of this region. Many of you may know that we conducted the first online lecture series on atmospheric physics jointly with the SRM Institute of Science and Technology, Chennai, for 4 months during January to April this year, in which more than 2,000 people from 48 countries registered for the course. Then we conducted the second online training on the WRF modeling system, jointly with the CDAC, that is the Center for Development of Advanced Computing at Pune in India, during 3rd to 24th April 2023, with hands-on training on the supercomputing system of CDAC. So the participants from the other countries could get a chance to remotely log into the HPC of CDAC and do the hands-on practicals also. And this is the third attempt on the capacity building of people in satellite meteorology. We have a distinguished panel of very senior scientists and professors from reputed institutions of this region who are experts in the fields. The syllabus of the lecture series has been designed based on the feedback and requirements of the member countries of SAMA. This lecture series is targeted to postgraduate students and professionals of non-meteorological background started on 2nd September and will complete on 20th of January 2024. As announced earlier, certificates will be given to the participants who will attend at least 75% of the lectures. Those interested in getting the grade certificates like outstanding or excellent or very good, good, etc., they will have to appear in a evaluation test which will be conducted at the end of the lectures. The lectures are live streamed on the YouTube channel of SAMA, as you know. They will also be available afterwards on the YouTube for those who could not attend the course live because of the time differences between India and many other countries. As you know, people from so many countries in the West Africa, even some people from Europe, Far East Asia like Indonesia, Philippines, even I think one or two from Japan also are there. So there is a wide range of geographical locations from where the people have registered. Basically, most of them are the member countries of NAM, that's a non-aligned movement countries, which is also an institutional member of SAMA. So therefore, for the benefit of them, the lectures will be available always afterwards also. They can view the lectures later on. We shall try to have interaction between the speaker and the participants in this lecture series. Please write your questions in the chat box. Our moderators will pick up the questions at the end of the lecture, and then they will be answered by the speaker. So enjoy the lecture and wish you all the best. On to you, Dr. Ashim Kumar.
Thank you, sir. So for welcoming the panelists as well as the participants and also providing the a brief overview of this program and earlier programs. So as per agenda, we need to have address by Professor AVM Ajit Tyagi. I think due to his, I think sir did not come today.
Thank you, sir.
Yeah, so I think now we can move on to next session. I request Dr. Rohini Bawar to introduce today's speaker, Dr. Ashim Kumar Mitra. Over to you, Rohini.
Yes. Share my screen. So it's a pleasure to introduce Dr. Ashim Kumar Mitra. Currently, he is working as a scientist F and associate project director of multi-mission data processing system of INSAT 3D and 3DR at Satellite Meteorology Division of IMD New Delhi. He joined IMD as a meteorologist through UPSC in 2002 and later obtained his PhD in quantitative application of remote sensing in weather forecast from Jadavpur University, which is in West Bengal, in 2014. He has 20 years of experience in satellite meteorology and looking after the operations and utilization of INSAT Kalpana-1 polar satellite data for different applications such as weather forecast and climate studies. He was instrumental in utilizing of INSAT 3D, 3DR satellite data in the RGB preparation, disseminations, and NWP model assimilation. He is also associated with INSAT 3D, 3DR calibration and validation program and recalibration of past INSAT data for climate change. Dr. Mitra has been engaged in research in operational meteorology and atmospheric science for last decade. Since last year, he is also heading the geospatial group of IMD and made available the various products to the forecasters and users, or we can say stockholders. Awards. He is the recipient of Ministry of Earth Science Award in 2015, which is called also as a Certificate of Merit for his outstanding contribution in the field of atmospheric science and climate change. So welcome, sir, and we are eager to hear the lecture. Over to you, Dr. Lakshmi.
Yeah, thank you, Dr. Rohini, for introducing today's speaker. So now I request Dr. Mitra to take over the session. Over to you, Dr. Mitra.
Thank you, sir. At the outset, I would like to thank Professor Das sir, Dr. Ajit Tyagi ji, and all the SAMA members, SAMA committee members, and all the coordinators, particularly Dr. Swagata Parya, Rohini ji, Divya Prakash ji. So, and then the counseling member of Dr. Thapliyal Saab from Space Application Center. So I think today's lecture is basically is a very application or operational oriented lectures, and I would suggest everybody that they should look into it, and even if they required kind of any more or extended information, they can pass through Sama or NASA or to they can write. So let me share my screen. Just please let me know whether are you able to see.
Yes.
Yes, sir. Yes.
Yeah, okay, okay. So once again, thanks. Good afternoon, all of you from India and other countries, other parts of the world where they are observing or they are seeing this particular presentation. So basically, I'll be focusing on capability of current operational Indian geostationary satellites, particularly emphasis on INSET series, INSET 3R, and various products available with their application and use of rapid scan. This is also one way of I will explain it. So before we are going to the satellite and then satellite meteorology, now we need to understand that what kind of geography we have, what kind of hazards we are experiencing. If I can short it out, if you can see the image, then there is many natural hazards which is influencing our this part of the world. If I start with the drought, there is 68% of area where we are sometimes facing this drought, and then forest fires. There is 65% of deciduous, 44 mega hectopascal area of India's area where which is covered by forest, and they are prone to forest fires. We have seen last year over Rajasthan, Madhya Pradesh, earthquake recently, and even yesterday also we had in Nepal, and there is a casualty took place. Then there is a flood that is we are prone to area of northeastern side and then eastern part of the country. Heat waves and cold waves that we are basically they all are the same area that we are or we are facing this particular cold waves and heat waves, the different seasons. Cyclones, that there are two seasons, and basically these two seasons are you can see 7,500 kilometer long coastline where this is a vulnerable area where we are facing heavy rainfall and flash floods. That is the two monsoon season, that is a southwest monsoon and northeast monsoon, and then thunderstorms. The most part of the country, anytime it is a vulnerable. We have seen last time in Chennai, Bangalore, Ahmedabad, Hyderabad. We have seen that with an hour or two, entire city flooded with. So basically, what exactly I would like to mention here that there is a to observe this thing. There is a huge data sparse region that is know that due to the Great Himalaya to the north, Bay of Bengal to the east, Arabian Sea to the west, and Indian Ocean to the south. So these are the area where data sparse is the most you can say the hindrance part where you can influence it. Now, it is not only influencing what I'm explaining the natural hazard. These natural hazards are not only influencing or not only impacting the India. It is also impacting the other countries like SAARC countries where Sri Lanka, Nepal, Bhutan, Afghanistan, all these areas you can see over the area. Somewhere the affecting. So, to understanding going for the satellite meteorology, we need to understand what kind of natural hazards we are facing with and what are the timelining of means how they are how what is the season and what kind of a weather is impacting. Like you can see over this part of the world, winter is January to February, where WD, western disturbance, cold wave, fog, heavy snow, frost. Similarly, pre-monsoon thereafter comes cyclonic disturbances, heat waves, thunderstorms, squall, hailstorm, and then it comes to the monsoon, June to September, heavy rainfall, floods, droughts, and then post-monsoon, that is cyclonic disturbance, northeast monsoon, particularly over the heavy rainfall area. So now we have categorized this season with the number of months and number of impacted weather hazards. Now, when we come to the satellite meteorology, then we have to understand what kind of this mechanism plays, what kind of weather system basically it has. And if you see in this particular chart, there is a northern part, if you can see, there is a western disturbance influence. And if you see the blue color, where the fog area has been completely disrupted by your day-to-day life, as well as where the area of the people who are living in this area, particularly from northwest to Gangetic Plain, and it goes to the hilly area of your Arunachal Pradesh. And then thunderstorm PS, you can see there are many occasions where thunderstorms, and then you can see the onset of vortex, that is OV, during the early you can say times of your monsoon. And then easterly waves, that is also plays a very important. So before we go to the satellite, we need to understand the geography and then your synoptic systems. These are the synoptic system which is very important. If you do not know the synoptic system, it will be hard to interpret the satellite imagery. This is a very strong line, that if you could not understand synoptic situation, you cannot interpret the satellite. However, you can see the cloud, but you cannot interpret it. Like how monsoon lows are repeating, how tropical jets are coming, how western disturbance are behaving, how your weather system pertaining to the kind of a weather which is impacting or vulnerable can be seen over the satellite image. That is the most important part. So there is a growing demand, you can say, need of improvement of weather, particularly for the temporal as well as you can say and seasonal scale, where climate prediction at very high resolution improved accuracy is required. So demand of high quality observations is very necessary for the current space-based observations. And as you know that we are going with the 5 trillion economy. So building the climate resilient smart cities are also important, and that can be achieved by the geospatial information as well as suitable early warning system. If you see this year, WMA is also 9 EWS for all, that is early warning system for all, particularly those countries where they do not have those satellite or equipment, where how early warning system can be provided. So building this climate resilience is also very important. So effort in this direction, particularly due to the climate variation projected in flash flood, urban flooding, widespread river flooding. There are many, like you can say the presence of pests and diseases. This can only be addressed by sustainable manner, by strategic planning, proper climate inputs, land use planning, weather information, and remote sensing. So at present, from Indian Meteorological Department point of view, we are utilizing the INSET meteorological satellite, which is helping us operational meteorological services in a real-time basis for providing the timely warning for extreme weather events, minimizing the loss of life and property. So keeping in the view of that high spatio-temporal resolution forecast and regular monitoring of atmospheric and oceanic state, there is a clear and recognized need for advanced instrument on board which are geostationary satellites. So I will start with the current one, means how geostationary satellite is basically helping us and improving the weather prediction model by providing the improved initial state of the atmosphere and ocean. The broad areas of science and application where geostationary satellite plays very important role over this part of the world. We have seen from almost like 3 or 4 decades that monitoring of the monsoon progress, how monsoon onsetting and active can be seen. Now casting, that is for next few hours, short to medium rain forecast up to 10 days, particularly agriculture, flood monitoring, western disturbance, heat and cold wave, extended range forecast up to 1 month, agriculture application, active break phase during monsoon season, agrometeorological services. So there are many services that I am listing out, which is helping from this geostationary satellite. So air quality monitoring, climate monitoring prediction, energy application, that is wind, solar energy forecast, forest, industrial fire, and ocean application, particularly SST and geophysical parameters. So you have seen that there are a number of there are many sectorial application needs to be, or it has been developed so far since last 3 decades from the geostationary meteorological satellite. This is our satellite meteorology division, which is start functioning since 1970. From 1972 onward to 1982. That particular time, IMD used to receive the satellite imageries of NOAA and NASA meteorological satellite through secondary data, satellite data utilization center, and images were printed on photographic paper for using in weather forecasting. From 82 onward, you can see there is a long achievement or milestone being achieved by IMD, especially the Space Application Center and IMD jointly. And you can see from one set, set 1A it has started, and now we reach and now the 3DS is also about to launch soon, and then new way of hyperspectral signature of how multispectral hyperspectral signature of visible IR can be seen. That could be the upcoming satellite. So this is the planning of Indian satellite system, where previous speakers past speakers have also been explain it. I'm not going to the deep. This is the multi-mission our data processing system situated in Lodi Road, New Delhi IMD campus. So it is established in MMR-DPS, that is multi-mission meteorological data receiving processing system. We have a ARGAWS receiving system also. Basically, our system comprising the Earth station. You can see the lower panel with this animation where Earth station, data acquisition system, data processing system, storage, data supply system. All these things are being available as a tool of state-of-art technology. And the most important part is now that the processing system, which was earlier 15 minutes, earlier when I'm talking, that is a 6 year or 10 years back, it was 15 minutes. Now it is cut short to 7 minutes, and has provision to update calibration coefficient in operational change in Calwell site G6 data. So with the association with the Space Application Center and IMD, we are also calibrating this data. So one can go and they can utilize this data for their kind of meteorological and climate studies. The system is capable of process the rapid scan data also, that I will explain in my next slides. Now I'm not going to the deep in this because the past speakers have already explained. The most important part which I would like to mention here, that in India particularly there is a paradigm shift of the monitoring of the observation from satellite, particularly from INSET, has been noticed in 2013 when INSET 3D was launched, and 2016 when INSET 3DRs were launched. So after launching these two satellites, the paradigm shift when I'm talking about, that means the way of monitoring has been changed. And because of the two channels, you can see the number of two channels. These two channels are shortwave infrared 1.5 to 1.7 micrometer, and medium wave infrared, that is microwave, that is MIR, that is 3.7 to 3.9 microwave. So these two channels, which we would not have any in our previous satellites, these two channels has played a very, very important role. And observing the system, particularly as I mentioning that the fog, dust, or thunderstorm, or overshooting top, this entire our southern Asian part, these two channels has played a very vital role. Some of them I will also give an example. This is the operational scenario of how INSET 3D 3DR could scan the Earth, particularly from the vertical sounder, that is a INSET 3DR temperature and moisture profile from 3D 3DR. This was a scanning geometry. I'm not going to the deep of this. Now, first I will start with how satellite. What is the prime? You can say the advantage of satellite is that nowcasting. Now, satellite nowcasting is what? Because whenever you see the satellite imagery, they have instantaneous image. So with the help of those instantaneous image, you can be able to better predict to the next few hours very with accurately. So accurate forecasting is very, very important, because initiation, temporal and spatial scale, and immediate impacts of thunderstorm remain a significant problem we have seen in the aspects of meteorology. Because from the forecaster point of view, convective cloud clusters of synoptic and mesoscale, particularly from 200 to 2000 kilometers, as seen on satellite images, take no less than several hours to develop, mature, and dissipate. Where a single cell thunderstorm in the cloud cluster may form and vanish in tens of minutes. So this is the kind of forecasters, you can say, the experience to understand this, how convective cloud could behave. Now here, satellite cloud top temperature, basically it is atmospheric temperature at the level of cloud top. So satellite cloud top temperature, which spans relatively longer in time, serves to indicate a certain extent the life cycle from formation to dissipation of the entire cloud cluster, and motion of the cloud cluster also hints the large scale movement of the entire system. This is a very, very important for any satellite meteorology they are sitting or they are seeing this presentation, because with a CTT or satellite cloud top temperature, they will give us with the sequence of, or you can say the number of images in the sequence of life cycle of formation of the cloud and its dissipation played a very, very important role, that we have seen many years, that how the formation of this cloud can play a very vital role for any kind of disasters. Like Like if you can see this image, this is the kind of image where I would like to make a point that how IR imagery with the radar echo can play a side by side. Like you can see a radar scanning every 10 minutes and we are scanning every 26 minutes of half an hour. So in 26 and 10 minutes, you can see here, then you will finding out satellite observed cloud top cooling precedes significant radar echoes by 40 to 60 minutes earlier. Now you can see the reflectivity. This is a 40 GB, around 38 GB, and you can find out every half an hour image of satellite IR. Then you will be finding out minimum temperature of IR, cumulus BT, and beating cooling rate can be well defined here. How beating cooling rate can be -7, -11, -5. So the point here I like to explain is that IR image representing significant information to the radar echoes. So here, every 15 minutes or half an hour imagery of satellite plays a very vital role, because in operational NW, why satellite nowcasting is important, if somebody asks, then you can simply explain in this manner that operational NWP has difficulty in correctly forecasting convective initiation, timing, and location, because all about model run 6 hour or 12 hour or sometimes 3 hour. But high resolution cloud resolving model that is particularly less than 10 kilometer, NWP guidance provide only scenario of what could happen, but whereas satellite imagery shows what is happening. So this is a very important. What is happening, that is a part of satellite nowcasting. So compared to the smaller scale convection as resolved in radar, the motion as seen from satellite is more stable and orderly. So that is a very important. And then it comes to the what kind of product you are going to see. Past speakers has already explained about number of products derived from inset, but here I'm giving you the kind of a threshold what basically one can see in the satellite imagery while going for the satellite nowcasting. That is the HEM, hydro you can say the hydro multispectral rainfall, HEM, IMR, instant multispectral rainfall. So these products, if you're finding out every hour or every instantaneous image, if the rainfall is exceeding 15 millimeter per hour, if CTT, that is the cloud top temperature, is minus 220 K to 255 K, if OLR value is getting down from less than 160 or 150 K, and along with that BT of the BT, that brightness temperature of shortwave IR and thermal IR channel using RGB products, and then animation. So these are the threshold. Yeah, you can say the layman's language, it is a normal threshold where one can see by seeing the satellite image for satellite nowcasting. So if you go with this threshold, you'll be finding out that how deep convective clouds can play a very important role, and how they look up to. Like usually they identify by their cold cloud top 10. If I say deep convective cloud means cold cloud tops, which emits low value of outgoing long wave radiation. Now you can see that 150 to 160, that you can see here, this is Andaman, the circling it, and then here, then slowly, this is the area where very deep convective cloud are being observed. So this is the area. These are the kind of signature that one can find out. And then it comes to the cloud top temperature, which I was talking. You can see over the right from the Lakshadweep to your Andaman, there is a strong belt is developing, that convective cloud is forming. Now you can see it is a forming every half an hour imagery. You can see it is developing, and then finally you can see here that there is strong, very deep convection has been developed. Now, so one can relate it with the kind of a cloud classification. If there is less than 220 K, there is a very deep convection. If the temperature is between 220 to 235 K, there is a deep convection. And if there is a 235 to 255 K, there is a background convective cloudiness. So kind of a classification from the cloud, you may able to interpret it what kind of scenario could be developed in 2 to 3 hours, or you can say maximum 6 hours. So the nowcasting part is very well and addressed by cloud top temperature. So that was the nowcasting part. And then now I'll shift to the RGB product, which was also been explained in the past speaker. But again, I would like to emphasize on here that since we are looking up to the number of products and number of images and number of byproducts from the different imagery, this is the product which is being developed from the UMET set in earlier 2000, and then it becomes very habitual for utilizing the multispectral RGB composite for qualitatively false color image, basically enhancing the specific feature. Now, since we have a multispectral signature in the 3D, low cloud, fog, fire hotspots, snow, ice, or you can say kind of a dust, convection, air mass characteristics. Now this can be seen very well because red, green, blue. This red means this particular red, there will be beaming of visible and SWIR channel. In a green color, we are putting the MIR channel, and the IR putting. And while combining it, you may be seeing the right hand side, there is the RGB product is available. So this is a 10-bit false color image created by combining band or band differences into each, you can say each of the red, green, blue component with defined SCPs. The advantage of RGB product is the ability to look at the single image to identify a feature instead of analyzing multiple single image. So multiple single channels. So here I would like to mention here that so with one image you can able to. So there is as I mentioned that in 2013 and when 14 insert 3D was operationalized with the help of RGB and the one tool that is rapid. The scenario of weather forecaster to observe the storm or any kind of weather hazard has been changed. There is a lot of improvement and accuracy has been noticed and you can say the recorded from this part of the forecasters, and our accuracy has been also very improved. How RGB is developed, as I mentioned that it was basically the MSD, Imager and Severi, they utilize the RGB product, but since we do not have the same channel what Severi has, so we also it is customized. We customize here with our own area or our own land and our own weather product. We have made our insert 3D product into the RGB line. So what basically it is, I'm not going to the deep because past speaker have also explained it. Now visible channel basically is the reflectance and red approximate to the cloud opacity. So here, and then you can see here, you'll be finding out that SWIR channel basically give you the solar reflectance in green is a qualitative measure of cloud particle size and IR is basically the brightness temperature modulates the blue color as I mentioned, as I shown. So basically these RGB in the daytime, DMP basically daytime microphysics is naming of DMP. So this is a very useful for cloud analysis, convective fog, snow, fires, and these colors do not precipitate appears white because the water clouds could not you can say the precipitate because cloud drops are small whereas large drops are the typically to precipitation cloud appear pink. So color is a very important here. Now you can see here then the lower panel CB cloud look like brick color, CB cloud small droplets look like orange, off orange, water cloud look like a green, maritime cumulus cloud look like the violet, and then yellow is the mid-level orographic cloud. So similarly, snow is a magenta color. So super cool water cloud appears more yellow because of the lower temperature that modulates the blue component. Similarly, cold and thick clouds with top compared to the large ice particle, that is tops appear red. Optically thick clouds with small ice particle near the top appears orange. So this is the physical significance of the product, but utilization is a very important. How you are interpreting now. This is the daytime microphysics RGB image. Now you can see this image. This is a lot of information carries in one single RGB. If I can start with mid-level orographic cloud, you can see over this part of the area, and then from the Arabia, the flow of dust can also be seen, and then over the Tamil Nadu area, there is a cirrus cloud can be well depicted. And then if you go to the lower latitude, and you can find out there is a mature CB cell that is a brick color. So this color basically mature CB cell, and then sun glint can also be seen over the you can see over the southern part of the Andaman, or you can see over the and then you will go to the main part over the northern part. If you can see snow can be seen very well in the magenta color, and within a snow you can also see the WDs appear. So western disturbance can also be seen with the snow cover, and then it is a passing of WD can be also. So my point is here that with the one single imagery with the multiple channels, one can combine in the RGB format, and it can infer a lot of information with the one single imagery, and that change our perception to observing the weather phenomena. And this is the night time. So night time, because since we do not have a visible and SWIR, so we utilizing here IR1, IR2, and then MIR channel. Now this is also very important because in the nighttime condition is different than the daytime, because in nighttime the particle phase size is also very important, particularly to know the water cloud and small particles. Similarly, IR and red color, basically the thin cloud, can be seen from 12.4 to 10.4. That TIR2. So that part is very, very important here. TIR2 plays a very, very important role in the nighttime. So now nighttime imagery, we can see the flow of dust can be seen in the orange, or you can see the magenta color. You can see here, and then fog could be look like you can see here. The fog is also looking very, very you can say the distinguishable form. Why I'm saying here, because the why change has been noticed by INSET 3DR, because prior to INSET 3D 3DR we do not have any every half an hour imagery, or you can say every 15 minutes of the image. So we were waiting for nighttime fog detection from NOAA satellite, and you may be aware that prior to 2030 NOAA passes were coming only twice a day. So it is very difficult from the area where it is passes gone through, you will be able to detect your fog. So it was restricted our fog detection. But with the help of India, every 15 minutes, the fog can be identifiable in that change our many more sectorial applications distributions, like aviation sector has been get benefited with our these images. Now, rapid I have already talked about, because real-time analysis of product and information dissemination. It's a web-based quick analyze tool, well developed by Space Application Center and the Meteorological Department jointly, and they connect atmospheric and geosciences into that. It has a kind of a web mapping services. It can be used by any community, because the digital data is available. One can use the many features: color, opacity, thickness, time series, vertical profile, transect, area measurement, distance measurement, like animation, RGB. So many things can be seen, like imagery. You can see the fog is also there, and as along with that, the satellite cloud, or you can say the moving of the cloud can also be seen. Now I'll give you example like how these things can be seen. Like there is one option where how observing fog can play a very, very important role here. Like if you can see here, just a minute, that this is the TIR1 4 UTC by SWIR visible. By 4 UTC, you may be seen there is a kind of a clouds, but when you have to the visible image, you may find out the somehow horizontal blanket. Fog is a layer of fog can be seen. But if you can see the SWIR imagery, you'll be finding out there is a strong reflection. You can say from SWIR channel at 4 UTC. But you can see there are many more other things are also there that you may not be able to see now, but I'll show you how you can be interpreted. So if you can see, this is the valley fog. Now this arrow is pointing you at particular area, that is a Srinagar. That is a valley fog can also be seen here. That is the most distinguishable thing from the SWIR channel can be found out. Whereas visible imagery you will not able to find out, because it is mixing with your eye cloud. So if I can see broadly with these two images, SWIR visible and this, then you can see very, very distinguishable form in SWIR imagery. But if I can see from the RGB, how it can be look like? Now look at this. So it is a clear-cut identification. Where is the fog? Where is the snow? And where is the clear sky? So over the Gorakhpur, or you can say over this area like Pilibhit and northern Uttar Pradesh, there is a fog, and there is also fog in over the area of Srinagar, valley fog, and which is surrounded by the snow cover. That is the pink. You can see the magenta color. You can see here. That is a snow. So that is what I'm saying, that the understanding of weather phenomena from the satellite multispectral signature as well as the RGB has played a very, very important role in Southern Asia, particularly the India. Now, daytime fog product, you can see here. You can also, we also have a IR fog low cloud product and also RGB. You can side by side also you can compare with for validation. In this manner, we have also prepared a kind of a checklist, or you can say the threshold for identifying the fog. How fog can be like TIR2 minus TIR depends if it's positive, and if the TIR minus MIR more than 2.5, and if there is a brightness temperature more than 279 K, that is a Kelvin, so there is a fog. And then what is the time period, that which time window you would like to see? You have to see the 13 UTC to 2 UTC of next day. So between the night time, you have to use threshold. And if you daytime, if you go, then TIR BT will be around 255 to 275 K. Visible will be 30 to 45%. SWIR would be 31 to 60% for low cloud. Whereas for fog, you'll be finding out fog, it is at 276 to 290K between TIR in the daytime, and would be 65%, and SWIR would be 31 to 60%. So one thing is always been shown here, that during the fog or over the fog, where the brightness temperature or you say the percentage of this channel exhibits very distinguishable results. Like for fog, there will be SWIR channel always be higher than visible channel. So this is the kind of a thing that we have formulated here, the device in our forecasters notebook, that how they can look up the fog during daytime. Similarly, during the night time also it has been given. Now, sometime people are asking that I have to verify it. Now you can see here the left hand side, there is the visibility, you can say the chart over the Indian region can be seen. That is the red part is, that is a meter, 50 meter, you can say 500 meter, 200 meter, 100 meter, and alongside you can say the right hand side there is a RGB image. Exactly the same nature of the fog pattern has been capturing. Even 6 UTC also, if you can see, those areas has been reporting very the fog is also been visible to the RGB imagery. Now I'll go to the dust storm. Now dust storm is also plays a very important role. Now you can see here that over the Arabia or the Arabian Sea, northern Arabian part, how dust can be well detected by this your RGB imageries as well as your rapid tool, that you can find out that over the these are the 2-3 points where temperature is always been warmer. So one way of how dust can be seen, dust the temperature will be always higher than 280 Kelvin, and along with that, you can see your SWIR channel will also be higher than visible. So that, what does that mean? That means that the particular particle or pixel is not absorbing anything; it is reflected back. That is a major, you can say, distinguishable point of dust. Your IR will be higher and your SWIR channel will also be showing the higher reflectance percentage values. Now you can see here this imagery. This is a dust storm season, sends particulate matter across the Arabian Persian Gulf. Sentinel-3 imagery you can see for 13 March 2021. Very good imagery you can see on the left hand side. But if you see the right hand side, there is an inset RGB image is also available. The most important part of this, that the sentinel imagery is no doubt about that. Their resolution is very high, but the availability for the forecaster is very poor. Like available once in a 2 days, whereas inset RGB at right hand side you are getting it every 15 minutes. So now what forecaster required is, as I mentioned in my initial slide, high spatial and temporal resolution. So spatial is either 1 to 4 kilometer and temporal is every 15 minutes. So this is helping us a lot for finding out these kind of disaster weather events. Now this is also one way of long back over the Lucknow station. There is over 4 o'clock in the evening. There is a complete darkness, and if you can see one by one how the one patch of the cloud are moving it, as you can see in the middle of the image, that one cloud patch is moving towards from west to east over Lucknow side and giving us the rainfall. Along with that, if you can see the satellite imagery, the wind information is also here very important. That wind direction, wind speed over the middle and upper lower level is very important, and they are depicting exactly the nature of how rigorous thunderstorm, you can say severe thunderstorm, can play the important role. Now you can see here that because of the circulation pattern during the particular season, the synoptic system, you need to understand, as I mentioned, that there was a cyclonic circulation over Rajasthan part and over Uttar Pradesh, and it is moving towards eastern side, and then you can see the TIR-BT has reduced to almost 190, 180. So kind of information like you can see here, like in Delhi in 2019, when the dust can be seen from the cloud, along with the wind also, if you can put into the right hand side, wind speed also, because there is a system. The first thing which I have mentioned before a start, without understanding synoptic signature, very difficult to interpret satellite imageries. Now you can see that there is a circulation pattern over the Pakistan and Afghanistan, and that brings the high speed, and with that speed over the Rajasthan, there is a dust storm along with the thunderstorm cell is also being developed, and this part is very well captured by this threshold, if you can see here. And then you can show the Rajasthan dust storm claimed 17 lives over 7 years. Now you can see here how the storm can play a very, very vital role for the human life. And it can also be seen that how satellite imagery side by side can also be getting every 15 minutes with this information. This is a day and night time micrographics. You can see over the Arabia, there is a dust part can be very well seen. So the forecaster what basically required. This is the one information that they get, and then they make it to the kind of advisory notice, the bulletin with the associated with the other synoptic situations. And then you can see here, this is over Rajasthan on 2015. There are two different way of color by RGB can be seen. One is a brick color, that is a strong thunderstorm. Ice particle is also there, but at the lower level you can see there is a strong dust movement. Entire area, that is red part, is showing the dust part. You can see here the SWIR channel. SWIR is very, very high. One can go to the rapid and they can check it with also. So it is SWIR channel is getting very high as compared to visible, because there is no absorption at all that particular pixel. So there is a clear cut distinguish between the ice water, or you can say the water droplets of the cloud, and dry, you can say the dust. So this dust and these things, the liquid water content of the water of cloud can be seen very well from these RGB imageries. Similarly, heavy rainfall, if you can go, now you can see here, day microphysics showing fall in SWIR channel. If you can see here, that small, you can say the graph, in the green color represent the SWIR. So there is a fall in SWIR. Now SWIR fall, what does that mean? SWIR means shortwave IR. Once it is the percentage is getting fallen, that means it is absorbing. Once it is absorption is there, that means there is a cloud pixel will be a very dense cloud. Deep convective nature of the cloud is developing. At the same time, you'll be finding a rise in visible albedo. So SWIR fallen and rise in visible albedo, they play the very, very important role, because then there will be fall in temperature. This is a greater line, you can say, for forecasters. They can understand to get the very severe, or you can say rigorous thunderstorm. I may have to repeat it again. Fall in SWIR, rise in visible albedo, translate into the TIR1BT fallen. That means there is a severe thunderstorm, or you can say overshooting top of thunderstorm is going to develop, and the station could be informed and warning can be issued. Although there is a sharp decline of this thing, has already been given warning, and that can play the very, very important role for the nowcasting. At the same time, nighttime temperature, you can say nighttime physics, there is sharp fall of TIR1 minus BT and TIR1 BT. So both temperature will be fallen, because nighttime we have only thermal kind of information, or you can say the TIR will here, and as MIR will play the same role what SWIR and visible plays in the daytime. This is a product, that is HEM showing estimated rainfall, and IMR showing estimated rainfall. So you can see how the color of the rainfall can reporting to the higher number of rainfall in millimeter. But the first slide which I had shown, that is the main significance, that is science of the how interpreting the satellite imageries. Similarly, this is also one way of how the declining of SWIR channel for severe weather, particularly the heavy rainfall episode, can be seen. Now you can see here, you can see here that how sharply this time series plot of night microphysics can dip of TIR1 MIR BT, indicating the large instability. So the instability can be well seen. I am saying this because now you have a rapid and RGB, and you have a bits of scan. So you have a complete higher temporal and you can say spatial coverage of the particular events. So you can able to definitely get into the where the instability plays the important role. What instability, whether it is a large instability or whether it is the stable environment, that can be seen by from these particular channels, SWIR, MIR, and the third one is also, that is TIR. Now this is the fog, how fog can be seen. You can see the SWIR, as I mentioned that over the fog, SWIR will be always higher. Now I have pointed out here SWIR 53%, visible albedo is 26%. So SWIR will always be higher, and temperature will be always 270, 280 plus. That means above 280 plus temperature BT will represent the fog, particularly during the winter season. This is the night time. Now again, there is one classification also I'm giving. However, in a practical session, you may also go into into that. How snow, medium cloud, low cloud, and as well as your high cloud can be seen. With the help of their percentage, it can be interpreted. I will explain it in the practical classes. Now I'll come to the IR imageries, how it can be seen. As I already seen in the past speaker also, it has been spoken by IR imagery. I'll just give you the how it can be seen: the coastline, coastal free area, or you can say cloud free area. And this is the IR imagery. Low cloud can be seen. Thin cirrus line. Now you can see thin cirrus line, how it can be seen. Cloud free land area over the Afghanistan. You can see there is a darkness. So there is a cloud free land area. There is a CB cloud over southern part of Sri Lanka that can also be seen. So this is IR imagery. And water vapor imagery, basically what you can see, that is the moist area, boundaries. These boundaries are very, very important because they have the signature of the location of jet streams. So that plays a very, very important role, because these boundaries and moist area, they play a very, very important role over the northern part of the India during winter season. Dry area, then moist area, tall clouds. So this can be seen very well from the water vapor imagery. Some of the system, like induced system, what basically induced system? Occasionally under the influence of intense WD, cyclonic circulation is developed in the lower troposphere, particularly over the Rajasthan part, West Madhya Pradesh. So such disturbances are known as an induced system. You can see over the satellite imagery. This is the induced system because this system can be recognized as a low-level circulation in organized low-level cloud visible image. Example induced, as you can see in this figure, that this is a low-level circulation over Rajasthan part can be very well depicted. And then how it will be collide with the subtropical jet stream. That is my basically I would like to explain here. Subtropical jet stream is narrow band, fast-moving air flowing from west to east, and this subtropical jet in northern hemisphere flows between 25 degree to 35 degree north in the upper troposphere and height about 12 to 14 kilometers. So the wind speed is roughly around westerly stream is around 150 to 300 kilometers per hour, with extreme value sometime reaching 400 kilometers per hour. So seasonal migration of subtropical westerly jet stream is such that in winter, subtropical westerly flow from southern slope of the Himalaya, but in summer it shifts northward rather dramatically and flows along the northern edge of the Himalaya. So in early June and in late summer, along the northern edge of the Tibetan plateau. So this is the most important part, that during the winter, subtropical jet flows along the southern slope of the Himalaya. That we need to find out from the satellite imagery. Now this is, you can see the roughly westerly jet stream, that is a subtropical westerly jet stream is 80 knot. It is moving around just like your Himalaya, southern parts of the Himalaya, the northern parts of India. Now you can see here the wind speed is around 80 knots, and after that you will be seeing the wind speed is lesser, like 80 knot, then 60, 20, 40. So this is the synoptic situations of how a westerly jet stream flows during the winter. And if you can see, this jet stream is basically bifurcated by the Himalayan range of Tibetan plateau. This basically goes on to the eastern part, and then the two branches reunite in the coast of China. So basically this is a signature of how air subsiding beneath this upper westerly current gives dry out blowing northerly winds from the subtropical anticyclone over northwest India and Pakistan. So if over the northwest India and Pakistan, how this STJ plays the very, very important role, that I would like to mention here, that now this is winter, particularly tropical westerly jet during the winter can be seen like this. This is the latitudinal area and where actually these wind speed are. Now, if you can look at the frequency of this occurrence of jet core computed from model, this is basically the color line delimits the area where the jet cores are dedicated or detected with the frequency higher than 1.5 day per month in each given point. So this is computed by the model, and then I'll show you. This is the jet stream can be seen from our satellite imagery. First, I have shown you the synoptic. Second, I had shown you the model, how they computed, and now satellite pictures, how they can be look alike. So basically, it has a notice in the satellite imagery in a long shadow lines, sharp edge CI, that is a cirrus cloud, longitudinal CI band or streams, transverse band of CI information. I will show you in the imagery, then it will be completely clear to all of you. Now this is the area. Now you can see here that western disturbance basically is a mid-tropospheric to upper tropospheric mesoscale vortices This is very important because over the northern part in India, now from November to February, we have to face this kind of a weather where the western disturbance are mid tropospheric to upper tropospheric vortices are propagate along with subtropical westerly jet stream and bring heavy rainfall to Pakistan and northern India during winter. So very importantly, if you plot with the winds, it can be very well how the trough. Now you can see the trough between this color line, that is your half blue, yellow and green. In between the trough is moving around the WD. And then I'll show you now basically the climates of India and Pakistan and southern China encompassing the Tibetan plateau are strongly influenced by seasonal mid-tropospheric synoptic mesoscale vortices. So if you can see here over the parts of India and Pakistan where these mesoscale vortices interact with the Hindu Kush and Karakoram mountain range. So that part is very important because the interaction of these WDs plays very important role, and then cyclonic circulation in the mid tropospheric and lower tropospheric level, or we can say the low pressure area on the surface, occurs in mid latitude westerlies and originates over the Mediterranean Sea, Caspian Sea, and then Black Sea, and they come around from Iran and they give the rainfall. And now you can see here this westerly, basically how this subtropical westerly jet stream can be seen over the Indian subcontinent. Now, if you can see over the area during the winter, green area, if you can see during the winter, jet is strongest and farthest south, which is the axis typically lying over northern India. And westerly jet is pushed to the northern and weakened. So this situation reaches to the particular area, and then basically the interaction takes place, and then rainfall occurs. Now, how it could be seen from the satellite image? Now, IR and visible, if I can say, inset IR and water vapor imagery could be look like this. Clearly, that wind speed, what model or what synoptic situation has been prescribing exactly the IR channel is showing IR and water vapor channel. But here, one thing also I would like to mention, that do not see this in a visible channel. In visible channel, you may not find it to the SWG. Why? The simple answer is visible channel is only for low level cloud. So subtropical westerly jet stream that is around 12 kilometer to 14 kilometer could not be seen from the visible imagery. So you need to see only IR and water vapor. So since, as I mentioned, that upper level phenomena only visible in IR and water vapor imagery. So if no cirrus cloud are present but other high clouds are there exist, jet stream can still be identified by the cloud formation, and how it could be seen by the V shape, V and U shape, that I will explain you like this. You can see the jet stream, how the jet axis can be seen. Right side there is an inset image, left side that is a structure, that is a phenomena how jet stream can be seen. This is in internal part, the inner part of the core basically lies the jet stream. So sometimes people are saying now it is a cloud, so basically this is jet stream. No, it is the inside, that is the jet stream axis, and we can be seen. And the right hand side inset 3D imagery can be well picked up the jet stream phenomena. Then if you can give the overall globally mid latitude jet stream, how they can look alike. Subtropical jet stream will be look alike like this in water vapor imagery. I'll give you one example, live example of how we have seen in January 2nd, 2022. The good amount of rainfall over northwest India took place. This is January 2nd, 2022. This is, now you can see here, slowly it is increasing. Now third it is reached here, and then there is a forecast has been issued. 2 consecutive active western disturbance and their induced system with moisture incursion from Arabian Sea likely to affect northwest adjoining central India during next 7 days. It was forecasted in 2nd January. Now I'll show you how it will play the important role. Now you can see here, next after 3rd, 4th January, jet stream can be seen very well in the water vapor image. Now we look like, now 5th January it reached to almost your Rajasthan and parts of northwest India. And then now you can see induced system has been developed. Now jet stream has been clearly demarcated. And then now you can huge on Jan 7, and there is a good amount of rain. Now another product also I would like to show you, that is a satellite derived wind product. Now basically what satellite derived wind product is, vorticity, if I can say, vorticity can be thought of simply a counterclockwise or clockwise spin. You already know that low pressure area is associated with the rising air and high pressure area with the sinking air. So positive vorticity will give you a kind of, you can say, the counterclockwise spin produce positive vorticity, while clockwise spin in northern hemisphere produces a negative vorticity. Now, which one is depicting what? So basically, rising air while horizontal vorticity is important to severe weather. So positive vorticity is very, very important. Now you just look at the imagery. Now this is, you can see over the India, it has started from, just look at the Iran area, Iran. Now it is reaching to the Afghanistan. It is coming to the Afghanistan, and then you see it is a part of northwest parts of Pakistan and India. It is also submerged, and then slowly now you see here entire WE very, very beautifully vorticity product of insect has produced the subtropical westerly jet. This is the kind of a weather. Why I'm saying the accuracy has been improved. This is the reason, because this vorticity product from this derived insect product has played a very, very vital role. Now you can see here, and similarly now I'll show you the water vapor wind. You can see the left hand side. Now this is the high wind speed. You can see 60 knot winds are already been there, and then it is reaching now second, and then now you can see here. Now you can see that entire now trough is now along with moving over the northern part. Now it is induced system. Now it is reaching, and then you can see here. So rainfall, if you can see, there is 10 centimeter, there is a 9 centimeter, there is a 6 centimeter over the plains of northern India has been reported. Now because of the timing, I'm also going fast. Now it's a 3DR depicting, I already mentioned, snow, high cloud, low cloud. Earlier there was no distinguishable point from our channels, but now it is because of the channel availability, snow, high cloud and low cloud can be seen. This is the fog over the area of Jammu Kashmir to IGP. Entire area can be seen over the rapid, so it can be well given to the nowcast as well as forecast. And then this is the area where cloud, snow, fog, it can be seen from the digitally, because in the rapid digital data is also available. It can be seen very well from these products. This is the cloud and snow. Difference between the cloud and snow can be very well seen. How temperature plays a very important with the snow, mid latitude, high cloud, and surface. And this is the signature of thunder cloud, cumulus cloud. How small cumulus cloud during the pre-monsoon month appears. You can see small dot. They are cumulus cloud. Now that as I mentioned, that you need to understand the synoptic, because May and April, March, because of the heating, these cumulus clouds develop, and within an hour and two, it develop and reaching to the mature stage, and thunderstorm develop and dissipate. This is the what exactly we need to detect. And then this is the WD. Now this is the ideal example of how WD clubbing with moisture from Arabian Sea and impacting northwest India. There is a heavy rainfall, extreme rainfall occurred for Uttarakhand, Punjab, and particularly Delhi region, because it is clubbing with moisture. You can see the moisture incursion from Arabian Sea can be well depicted by this imagery for 8 January 2022. And then the other part I would like to mention here, that we are also putting this lightning data to the insect imageries. So merged lightning product can also be seen in the animation. So this plays a very, very vital role for announcing or alarming the people, because the northwest India, you see how lightning plays very, very, because lightning very, very alarming is the very, very important for us. We can alarm it with the deep convective cloud nature and imposing with the lightning data. So this lightning data is every 1 minute is interval, it is available. Cloud to cloud and cloud to ground is also very, very important. So we are putting both the cloud and cloud to ground and cloud to cloud to cloud and cloud to ground, both have been depicted in our satellite image. Now the rapid scan mode. Before that I started, I would like to take you to 1982 when insect one data we have been receiving. That time we are receiving for every 6 hourly. So the past we are scanning at every 6 hours, and so the temporal accuracy was 6 hourly. And then when we at end of the 2000, we reached to the 3 hourly image. So every 3 hour pass scan was available to the forecasters. With the help of Kalpana in 2004 and 5, we reached to the hourly image. So every hourly, and 2006 we reached to the every half an hourly. So now 6 hour to you can say half hourly we reached, and thereafter insert 3D and 3DR, with the help of these two 3D 3DR, we are getting this staggering image that is every 15 minutes. Now I'm talking about rapid scan mode from insect 3DR, that is the program scan mode during severe weather condition. Insect 3D will continue to provide normal scan, but insect 3DR, The block size has been defined. 0.5 degree north-south direction, number of scan line will be 40, and the time taken is a 45 second to one line. So every 4th and 5th minute, you'll be getting the image. Now you can see here, this is a been finalized with IMD, ISRO, and forecasting agencies. And from 2017 onward, the rapid scan mode has been started. And almost today, around 35 to 36 cyclones have already been rapid scanned. So every 5 minutes. So now you can see from 1952, there was 6-hourly image, and 2023, you have 4.5 minutes of image. So your temporal scan has been improved drastically. So now it helps us to nowcasting. So every 5 minutes, if your data you have, you can have a very better observations for nowcasting. Now this is the SOP for a INSET 3 rapid scan has been given. Evaluation is started from IMD New Delhi, MCF Hassan, and then it is triggering to the IMD New Delhi, and then forecasters, NWP modelers, and decision makers, government agency. It has been. This is basically the area of where rapid scan is basically been taken place. Comparison of various models, guidance, decision making process, warning product generation. These all things has been side by side, has been taken care by rapid scan. Now, this is the rapid scan views of funny. Just an example I'm giving you, because the lightning also we are putting into that. So that is also one way of how rapid scan and 1 minute of lightning can improve the understanding of every 5th minute, the nature of the, you can say, nature of the hazardous event for severe weather.
Dr. Ashim, just one moment. How
Yeah.
many slides, how many minutes still you need? Just
I think 10 minutes, 5-10 minutes.
okay,
only.
okay. You continue, please.
Yeah. So during the landfall, now you can see that during the landfall, fun is seen in the rapid scan mode. So in a way, the eye can be seen very well over the crossing side. So this animation can also be seen here like this. Now animation part plays very Titli and Luban. These two rapid scan at every 5 minutes. You can see very well from here. Now this is a dedicated web page for rapid scan image. This is the website. This is a website. It is available in a publicly, so you can get it. So this is you can get it. And why rapid scan is required? Just I would like to mention here that when you take the normal operation, this is a red color, and one is a 1 minute scan, that is a black color, and one is a rapid scan. So if you can see the internal variation could not be seen by normal scan. That is why we need rapid scan for thunder. You can say the kind of events which is to be required, like thunderstorm or cyclones or those events. Now this is the wind derived from the rapid scan. You can see the nature of the particular cloud can also be. This is the overshooting top, like decrease in BT or increase in BT. That can also be seen from the rapid scan. And there is a lot of scope for improvement for rapid scan, because the water vapor wind and you can say cloud motion vector also needs to be developed, like what GOES and other satellite is utilizing. INSET is also in the process for developing this atmospheric motion vector from rapid scan. These are the space-based input. Basically, we are providing all state government, central agencies, Indian Air Force, Indian Navy, Indian Coast Guard, CWC, SASE, DRDOs, many more things that I could not list it out. But the one time it is at the clicking on the site in our website is 11 lakh to about 20 lakhs per day. This is not what we have got during the cyclone, or you can say hazardous events, or you can say when the severe weather phenomena occurs, our sites are jammed with the almost 10 to 11 lakhs per hit. Future scope, as I mentioned, that CMB WVW from rapid scan also needs to be developed. New geostationary satellite products were also developed from you can say MMDRPS, where 1D war algorithm of SST, clear sky brightness temperature, cloud top pressure, staggering winds, and then CSBT, that sounder clear sky brightness temperature, is also being developed. Apart from that, Meteosat Himawari product available also from UMETCAS. We have UMETCAS system at here. SIMS data, SIA data also we are utilizing for forecasting. However, there are challenges. Though there has been a significant improvement in rainfall detection, but still there is a large-scale rainfall phenomena, heat waves, cold waves, snow. There are challenges in real-time detection of prediction of mesoscale severe weather events such as thunderstorm, lightning, hailstorm, squall, heavy rain. Needless to mention that while loss of life due to cyclone being restricted to less than 100 in 10 years, due to lightning still continues to be around 2,500 per year in the year. So loss of life due to lightning is very, very high. So what basically we need to ensure the operational continuity and utility of precipitation radar observation, lightning mapper, wind profiler, scatometer, profiling through geo-hyperspectral observation technique, optimizing the spectral resolution, temporal sampling, timeliness of observations, quality of data, development of application tool for nowcasting to short-range prediction. What step we have taken? That multispectral, as I mentioned, that multispectral MNIR and hyperspectral VNIR. These are the every 10 minutes scan over GISAT. GISAT is supposed to be launched in next year. That will also help us to boost our kind of a mechanism that we are preparing. INSET 4th generation is also in the pipeline, where lightning mapper and hyperspectral infrared sounder will also be accompanied with. So we are hoping that these two satellites will, with a better accuracy of quality assurance and with the Calwell and better estimation technique of 90 days of data assimilated into the model, as you know that 90% of data is being assimilated from the satellite. So there is an improvement in the forecasting accuracy will be there. This is the future scope: improved resolution, sampling frequency, quality of data, accessibility of availability, historical data, research on AI ML with special emphasis is also to be looking into the nowcasting and processing mode. With this, I would like to thank all of you, all the organizers, and all the coordinators of SAMA. Thank you.
Thanks a lot, Dr. Ashim Kumar Mitra. So now it is a time for question answer, but usually we do a customary photo sessions for that proof of this lecture. So please switch on the camera, Dr. Thabial sir. Yeah, and Ashim. Yeah. So yeah, I think right now we are only these organizers are available. So our specialist photographer, Dr. Mohan Kumar Das, will. Mohan is not in this. Yeah.
Yes, we are here.
Yeah.
Just a
So
minute.
Mohan, yeah, I'm also taking and you. Okay, I am also not there. What happens?
Yeah, now you are visible.
Yeah, I think something went wrong. Okay.
So everyone is in the frame, right?
Yeah,
Okay.
the possible one.
Yeah, fine.
So yeah, it's done. Lakshmi had some work instantly, so now the rest of the program I will coordinate. So now there's a time of question answer. So this is the time for Dr. Mili Ghosh ma'am and Dr. Dibya Prakash. So you can start the question answer session.
Yeah. It was a wonderful lecture, sir. Thanks for this very informative lecture. And just reading out few questions. This question is from Suvendu. The question is, what is the spatial resolution of INSAT 3DR? And the second part of this question is, for weather analysis, what is the minimum required spatial resolution?
Thank you. Basically, INSAT 3DR resolution of channels, if I can speak about, that is IR is we are 4 kilometer. Visible and SWIR is basically 1 kilometer resolution, and water vapor is 8 kilometer resolution. So now the second question which was been asked, that for weather models, what the best of accuracy of, or you can say what best resolution could be used by satellite. So here hyperspectral signature of you can say the nature of the satellite will play very, very important role for weather models. Now we have a, from geostationary point of view, yes, 1 kilometer is there, but if it is 0.5 or less than that, but you cannot also, there is a discussion was also there, you cannot take more data, more higher resolution of data less than 500 meter from geostationary scale. But from there, hyperspectral sounder imager or you can say radiance can play a very, very important role. At present, we do not have. We have a now multispectral signature, which is comprising from 1 kilometer to 4 kilometer. But it is advisable for the weather model. 0.5 will be plays a very, very important role.
Okay, sir. Thank you. Second question is, sir, from Shruti. And as per her, on creating RGB product, that is VIS plus TIR plus SWR is used, as you said. but the spatial resolution of the BIS is 1 kilometer, whereas that of MIR and TIR are 4 kilometers. So mixing these images will be having some spatial error or not?
Very good question. See, when we are deriving for a kind of a product which has a different sample spatial resolution, as I said, the visible in 1 kilometer and IR 4 kilometer. So what basically we comprising here that we are taking the 4 kilometer resolution of the data. Visible we are taking the 4 counts of. So that entire visible imagery of 1 by 1 could reach to the 4 kilometer. So we are you can say upgrading to the 4 kilometer scale of IR and MIR of this visible channel. So you can say the accuracy or anything which was asked was not basically, because we are not going for 4 to 1 kilometer downscaling. We are reaching to the 4 kilometer. So we are taking 4 kilometer of region, 4 pixels of visible imagery. We are converting into the 4 kilometer of IR pixels.
Okay, means final output will have a spatial
4
resolution of 4
kilometer.
kilometers.
Yes.
Okay, thank you, sir. And Dr. Deepak Prakash, next questions you can take up.
Yeah, ma'am. Thank you, ma'am. Thank you, Ashim sir, for delivering very nice lecture. So the next question is how. One question from Govinda Manna. How can a student download precipitation data from IMD for the last 20 years?
Precipitation data from satellite?
It is not mentioned. I think it may be from satellite or it may be ground-based data.
Okay, so from satellite it is available to us, because we have a number of satellites in the last 20 years, because one satellite could not be sufficient, because earlier we have a Kalpana satellite. If I can take from 2004 to 2015, and after 2015 3D and 3DR. So combining these two, it can be accessed from MMRDPS, IMD Satellite Division. They can write to us, we can provide it.
Thank you, sir. So next question of Jagdish Prajapati. How the cyclone intensity is identified in the satellite imagery?
Very good question. Basically, cyclone intensity, when we are talking about that, how the signature, what is the pattern of the imagery we are looking up to. So in a satellite imagery, while you are finding out there is a clear cut or there is a distinguishable point of band has been developed, and if there is a possibility of movement of this thunderstorm, as I mentioned, the rapid scan. In rapid scan, you will be finding out there are 100 or 1,000 sort of thunderstorm developing, overshooting tops and all these things, with the signature of the banding pattern of the cloud, because cloud is also very, very important role to understand it. If the cloud is showing you the kind of convective nature and their movement and spiral banding or those kind of CDO pattern can be seen, that means there is a chances of intensity, you can say, increment. So the imagery has a very, very important role. If you play the animation of the satellite imagery of the past 2-3 hours, you may finding out there is a signature of particular pattern. With the pattern, you can able to understand the significance, and that I'm talking about visible imagery. Mostly you have to look up to the visible imagery.
Thank you, sir. So next question is, ma'am, can I take?
Yeah, you can take.
Okay. Is there any parameter which will calculate flood risk at coastal region due to heavy precipitation?
Actually, the question is we can answer in a different way. Like we have a 3 set of rainfall derived product from insect. What is a hydroestimator, that is HEM. Another one is the insect multispectral signature, and third one is the GPI, that Ghost Precipitation Index. So all 3 have a different way of attributing the rainfall events. HEM is basically the heavy rainfall. IMR is basically light to moderate rainfall, and GPI is from seasonal scale. So as we have pointed out that any flood risk. So basically, wherever you find out there is a clear if you are identifying the cloud with a liquid water content, and if the error of, or you can say the computation of HEM is higher, say more than 15 millimeter or 20 millimeter per hour, you may be identified that area to be get flooded. But again, this is the question. This will be a subject to the area which you are looking for. Say if it is a northern part or northeastern part, then there is a chances of flooding is more, because rainfall, the area and the geography is such that their flooding of those rainfall plays a very, very important role. Whereas in the Rajasthan and the plain areas, there might be possibility that those rainfall cannot give the flooding. So calculation, it is completely a subjective. It depends on the which signature and which season and which area we are computing. But yes, HEM can be a very good vital tool for heavy rainfall prediction, heavy rainfall estimations.
Over to you, ma'am.
Yeah. Okay. There are two more questions. One is from Janvi. She is asking, sir, are any special radiometric calibration methods used in these digital imaging processes?
I think very good question. I would like to mention here that jointly IMD and Space Application Center has established the Calwell site at Bhuj, Gujarat. So regularly we had a campaign. We are going to have a campaign there, and last 4 or 5 years also the established site is there, IMD and SAC, near Run of Kutch. So what we are doing there, we are calibrating visible imagery, visible band. We are calibrating with the in situ observation as well as model data simulation. So yes, we are utilizing the 6S model, that is a radiative transfer model for getting coefficients from in situ as well as your satellite data, brightness, temperature.
Okay, thank you, sir. The next question is from Sapna. She is asking how we can get lighting data from IMD as well as from satellite.
Actually, basically, satellite, we do not have any lightning mapper right now. Satellite data can be provided to you, whereas the lightning data is available with IITM. We have a satellite, the imagery. If you want that image, we can have. But if you want lightning data, please contact to IITM. Dr. SD Pawar is there. They can help you out.
Okay, and sir, in continuation of this, there is one question from my side. How this CG and CC are segregated from total lightning?
Actually, if you see, there is a nomenclature and how this lightning forms. So if I say there is a cloud and there is a thunder is going on, then out of those thunder, there is a 20% of chances are there that lightning will reach to the ground. So amount of it, 100%, there is a 20% chances of that lightning to be reached to the ground. So then still this 20% needs to be extracted. So the data, what we do, we simply giving us the intensity of that particular portion where 20% has been reached to the red color, and the rest of the portion we are just extracting. We are eliminating. So only cloud to ground we are putting. But if we put the cloud to ground as well as cloud to cloud, then it is very difficult which area would be affected by cloud to ground, because their nomenclature is that in the atmosphere during the pre-monsoon season you will be finding many clouds have the cloud to clouds, but those do not play the very important role. So only the CG we are extracting from the data and we are plotting into. But if you plot both of them, most probably you may not get which area of 20% cloud to ground you are looking up to.
Okay. Thank you, sir. Now there is no. Okay, one question maybe there.
Yeah, there is a question from YouTube. Shall I
Yeah.
repeat? Or,
Yeah, you can.
the question from respected Satyendra Bhandari sir. He just wanted to mention, wish to bring out for historical completeness rapid scan available since INSET 2AB, and I used to advantage to study rapid movement of moon shadow over India on October 24, 1995. Okay, it is not a question, maybe he was suggesting us. Yeah.
Just a comment.
Yeah. So just a comment, yeah. So
So
yeah,
now,
there is no more questions.
yeah, no more question.
So the next ornament. Now I would like to invite Dr. Mohan Kumar Das, Joint Secretary of SAMA and also the Director of NOAMI. So now Dr. Mohan, stage is yours. So please do the vote of thanks.
Thank you, Professor Dr. Shagata Paida. Good evening, everyone. I am delighted to extend a heartfelt thank you for joining us on this special occasion, the 9th lecture of our Satellite Weekly online lecture series. Today, we had the privilege of exploring capabilities of currently operational Indian geostationary satellites and its available products and their applications, with a focus on the use of rapid scan images from INSAT 3DR for meteorological applications. This enlightening presentation is brought out to us by the esteemed scientist, Dr. Ashim Kumar Mitra from the Indian Meteorological Department, India. First and foremost, our warmest congratulations and deep appreciation to Dr. Mitra. His presentation promises to be not only informative, but also truly inspiring, adding to our profound knowledge in this field. Dr. Mitra's dedication to sharing this expertise with us is deeply valued, and we look forward to the insights he will provide. We'd like to express our gratitude to esteemed SAMA Executive Coordination Team member, Professor Dr. T.V. Lakshmi Kumar, Dr. Rohini Bhawar, Dr. Mili Ghosh, and Dr. Dibya Prakash for their outstanding efforts in guiding the session, introducing the speaker, and facilitating the important Q&A sessions. Their contribution continued to create an engaging and enriching learning experience. We also want to thank all the participants and attendees from around the world for aiding the diversity and depth of our discussion, making this program a resounding success. In closing, our deepest appreciation goes to the key figures who made the Satellite Weekly Lecture Series possible. AVM retired Professor Dr. Ajit Tyagi, Chairman of SAMA, Professor Dr. Somesh Sadash, General Secretary of SAMA, and Professor Dr. Swagata Paira, Treasurer of SAMA and Convener of this program. Their unwavering guidance and support remain instrumental in our journey. Thank you, and may you all have a splendid and enlightening session ahead. Thank you. I think there is a summary, how many countries. I think Dr. Swagata can share it.
Okay. Thanks a lot, Dr. Mohan, for the vote of thanks. But still, we would like to actually, from last few lectures, we are sharing the database with the presenter. So today, there were about 226 participants from 24 countries, and the number of students is more than 50%. So thanks a lot for this, that knowledge gain presentation, and I know it will continue for the next two classes as well. Yeah. So this is a ratio of male female and also other the background wise, that scientific. This is the age group. Yeah. And this is okay. This this one. Go to the previous one. Yeah. So the number of students are very high on today's lecture. Usually it comes around 50%, but today it covers more than 50%. So thanks, Dr. Mitra, for this nice lecture, and we know that it will continue for another two lectures. But when we were discussing that time that so practical will be in the in between, or you will continue the lecture and then we will start the practical. So what do you prefer?
I think next week I will cover up the practical session.
Yeah, people will be more active on that time, and then you come to know, and that remaining part you can add on the third lecture. That will be best.
Third, I do not know whether third will be required or not, because 1 hour time I would like to. I may finish it up with the third one also.
Okay. Okay. Thank you.
Thank you.
Generally, if it is a practical, then the participants would like to do the hands-on, and the hands-on will depend on how fast is their internet, because Dr. Mitra may like to provide them some links for the rapid scan products of this INSAT or other products of the INSAT, and then the participants may like to explore those products live, and if they find any difficulty, then they might like to ask Dr. Mitra that I'm not getting, or why it is happening like that. So such kind of things might be quite slow, and it may not be possible to complete all that which Dr. Mitra might like to say in 1 hour. Therefore, in fact, we kept this scope for 2 lectures, not 2 practical lectures.
Yeah,
and one
Dr. Ashim, if you are busy on the third lecture, if you have any other persons who can assist you on the third lecture.
Not exactly, but let us see how we can go with the practical, because I have a number of satellite imageries. Now I would like to ask a participant that they interpret it, what they are seeing, and I'll just give you some hints. If any participant say yes, I understood it, then if we answer it, then I will give some marks or something. It could be, but imagery I will show to them on a live, like the way I'm giving a presentation, and one by one I will ask. So whoever said correct, we can say yes it is, or otherwise I will interpret it in case they are unable to. So something like that I'm thinking of.
I mean, you can ask all the participants. Of course, most of them or everybody, except few, come with their laptops, or some of them are on desktop. Some of them may be on mobile, but those who on the mobile may will have some difficulty. But those who will attend on the laptops, I mean, you can tell them the link of these, say, for example, rapid scan products of INSAT, and ask them, okay, you click that link and see what do you understand, why different products
Okay.
available